Okay, there's kind of a lot of ways to do this. I feel like to find the total energy of the Earth in its orbit, the total energy will be 1/2 mv squared plus negative gm m over r. That's going to be our total energy, right? This is the kinetic plus the gravitational potential, right? Okay, so to find what that is, I feel like the easiest thing to do is to find the mass of the sun, right? So to find the mass of the sun, remember that we know that the potential at the surface of the sun, right, is equal to negative 1.9 times 10 to the 11th, and that is joules per kilogram, right? And we also know that that is equal to minus gm over r, and we also know what g is. It's 6.67 e minus 11, and we know that r is equal to, from the center to the surface, is 7.0 times 10 to the 8th meters, right? So figure out the mass of the sun, right? And then there it is. You know, little m, so that's the mass of the sun, right? This is the mass of the Earth, and you know that from the previous page, right? You know how far the Earth is from the sun. That's the 1.5 times 10 to the 11th. Oh, and then what is our velocity? Remember, velocity is square root of gm over r in a perfect circular orbit, right? We could argue that it's not perfect and circular, but let's not. Okay, so v is gm over r, and you know the mass of the sun. You know the radius is how far we are from the center of the sun. Happy hunting. There are other ways to do this. I don't think that they're better. I ended up doing it a different way, where I didn't calculate the mass of the sun. And I'll leave that up to the talented and gifted student that wants to do extra work. Maybe it's not extra work. I don't know. Okay, an asteroid strikes the Earth, causes the orbital speed to suddenly decrease, right? Suggest the ways in which the orbit of the Earth will change. Well, we know from doing our lab, right, that if the sun is here and we're in this more or less circular orbit, right, if we suddenly decrease it, that we'll fall to this lower orbit, and it will both be slower at the point where it overlaps, but faster where it's closer to the sun. They're definitely not looking for that. Although if you mention the it'll become more elliptical. That does give you one of the marks, right? Basically, what they're looking for is that we know that it's gonna lose energy, right, because of this impact. It's going to get closer to the sun, and therefore the velocity will increase because, of course, the orbital velocity is like this, right? But it's a little more subtle than that, and I'm not sure that more information is better. But it's going to be faster when it's closer to the sun, but actually slower when it's farther away. So, but they don't look for that. So, I don't know how to advise you. Should I advise you toward the truth, or should I advise you toward getting the marks? I got the marks and explained all that because there's multiple ways to get 2 marks, right? Outline in terms of force acting on it why the Earth remains in a circular orbit. Remember, if we've got an object that's moving like this, right, and we've got a force in the direction it's going or opposite, that it changes the magnitude of the speed, right? If this is our velocity and this is a force. Remember, though, if we've got a velocity that's to the side and a force that's like this, if they're at right angles, right, that it causes the direction to change in a constant manner, right? It causes a centripetal acceleration. I think one of the marks is to say that this force is provided by the force of gravity, right? And that it causes a centripetal acceleration. Anyway, good luck.